Hey guys, I am continuing with these ACT math questions that I categorize as unusual. These are the questions that I've seen many of the students that I work with struggle with most often. These particular questions can be found on the December 2016 released exam. Perhaps you all are using this particular exam that you found on the internet somewhere to practice with. And perhaps some of these questions you too are struggling with. And if you are, hopefully this will help you. So this is the third video I've made of the 2016 released exam set. With that in mind, let's get moving to the first question. Okay. They tell us we have a triangle. They tell us that AB is 6, AC is 12, angle A is 60, and AC is the longest side. They want to know which of the following statements about the measures of the angles in triangle ABC must be true. Okay, so let's start with doing this. Let's just say A's right. Let's just say, let me get my pen back here. So let's say A is right here. We know AB is 6, so I'm going to put B here. So I'm putting A up here, B over here, and from here to here we know is 6 centimeters. Now it tells us that AC is 12. So from A to C, I don't know, I'm just going to put like right here. Here's C. So from A to C, we know this is over here 12 centimeters. So this has got to be over here too. Okay. It tells us that angle A is 60 degrees. It tells us that A to C is the longest side. So AC is the longest side. If AC is the longest side, then angle B must be the largest angle. Because the longest side and the longest angle pair together. Now, mathematically, let's see if we can fish out relationships here. Well, if angle A is 60, let's make angle B 65. Let's just say it's 65. So 60 and 65 gives us 125, right? In a triangle, you have 180 degrees. So if we subtract the 125, we're going to get 5. 7 minus 2 is 5, so 55 degrees left over. Well, that would make C 55 degrees. And that would make sense because we know B is the longest side, therefore the biggest angle. And A is given as 60, and they don't tell us anything about C, but B must be larger than 60, and mathematically, we've just proven that C has to be the smallest angle. Okay, well, if that's true, which one of these statements fits the angle relationships here? A says angle A is equal to angle B. No, that's not true. Answer choice B says angle B is greater than A. Well, that's true. And angle A is greater than C, and that's true. So answer choice B fits our information. All right, let's move to the next question. So it says suspended from a ceiling. Suspended from a ceiling is a weight on a large spring. So here's my ceiling. I like to make sketches. We've got a spring, and then we got a large weight. I don't know, maybe it looks like this. Large weight suspended from the spring. The distance D between the location of the center of the mass, well, center of mass here, of the weight after t seconds, and the weight's equilibrium location at t0 is modeled by this function. So the function is D is equal to the sine. Well, sorry. D is equal to 5 times the sine of 4 pi t. So this equation describes a system. And it says, what is the amplitude of the function? Well, let's say you don't know anything about the sine. From this perspective, default back to the parent function of the sine. So, y is equal to the sine of, I don't know, theta, okay? What does the sine wave parent function look like? Well, starts at the origin, goes up some distance, comes down the same amount, and then comes back 360 degrees later to the x-axis. The amplitudes are -1 for the portion below the x-axis and +1 for the portion above the y-axis. That's the parent. Now, in this particular situation, we have 5 times the sine. Think of it like this. Let's say we have this graph of x squared. We know the graph of x squared is a parabola. That's the parent function. What happens when we put a number in front of x squared, like 2? How does it change our graph? Well, this is going to be twice every y value. So at every point, this is going to get much steeper. Let's apply this ideology to D is equal to 5 times the sine. Well, this 5 is going to increase the amplitude of our parent function like this. I'm not worried about the rest of the equation. We're just talking about the amplitude. So now our amplitude becomes 5 and -5. So what is the amplitude of the function? It is J, 5. Next question. I squared, they love this on the ACT. They will present I squared to you in equations and ask you to simplify those equations as well. You must remember I squared is equal to -1. Please memorize that. And in fact, in this particular situation, I'm going to ask you to memorize the first 4 values of I. I'll show you what they are in just a minute. So given that I squared is equal to -1 and that K is a positive integer, what is the value of I? So I raised to the 4K plus 2. They tell us K is some positive number. Well, what if K is 1? Then I raised to the 4 times 1 plus 2. 4 times 1 is 4 plus 2 gives us I to the 6th. So what is I to the 6th equal to? Okay, so here is where some memorization techniques come in handy, and you need to be memorizing these first 4 that I'm going to give you. I to the 0 power is equal to 1. I to the first power is equal to I squared, you already know what that is. They gave it to you, it's -1. And then I cubed is equal to -I. Now we need I to the 6th. So let's continue. I to the 4th, I to the 5th, I to the 6th, I to the 7th. Well, the cool thing about this, if you know the first 4, then you know the next 4. This is 1, this is I, this is -1, and this is -I. Now, we need I to the 6th. So I to the 6th is -1. Answer choice B as in boy. Okay, these first 4 that I'm boxing off for you, you must memorize. If you know the first 4, you can project the next 4 and the next 4 and the next 4. Memorize them, because I'm telling you, they're going to ask you this question again. This is almost a guaranteed question that you're going to see. You're going to see it created from other perspectives as well when it comes to simplifying equations with complex numbers in them. I've addressed that on one of the first 2 videos that I started this series with. Next question. Okay, so this is a question that's asking us to evaluate equations. For all real numbers A, B, and C, which of the following expressions is equal to the absolute value of A minus B minus C? Well, okay, let's assign some numbers to these letters. Let's say A is going to be equal to 1. Let's say B is equal to 2, and C is equal to 3. If we take the equation in the question, absolute value of A minus B minus C, and we substitute these numbers in here, so we're going to have 1 minus 2 minus 3. What value do we end up with? So 1 minus 2 is a -1. And then a -1 minus 3 is a -4. The absolute value of -4 is 4. So we need to evaluate the answer choices with the same numbers and find the answer choice that comes up with 4. I'm not going to do every one of these for you because I'm trying to save you time, but you can do this on your own. I'm just going to jump to the the answer. And the answer on this is answer D. So let me work it right here. So the absolute value of negative A plus B plus C. So that's going to be a negative 1 plus 2 plus 3. Negative 1 plus 2 is 1. 1 plus 3 is 4. Absolute value of 4 is 4. So they both check. So therefore, answer choice D. Now, if you want to work out A, B, and C and answer choice E, you can, but I'm not going to waste your time. Most importantly, see how I used small numbers to evaluate what they've given us. Let's move on. All right, so here we've got g of x is equal to x plus 1 divided by x squared. It says, which of the following expressions is equal to g of x minus 1? All right, so we got functions. And we want to evaluate g of x minus 1. So let me write this out for you. G of x is equal to x plus 1 divided by x squared. We want to evaluate g of x minus 1. So we're going to take x minus 1 and we're going to substitute it into each x. So the first x is going to be x minus 1 plus 1 divided by x minus 1 squared. Okay, well, real quick here. The numerator ends up being x minus 1 plus 1. So negative 1 and plus 1 cancel, and that leaves us x over x minus 1 squared. Well, x minus 1 squared, that's a binomial, right? Well, when you square a binomial, let me put it over here. X minus 1 squared, that means x minus 1 times x minus 1. Okay, so let's work this out, see what we get. X times x is x squared. X times the negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. So let's clean this up. X squared, negative x and negative x is minus 2x plus 1. So now we have x over x squared minus 2x plus 1. That's what g of x minus 1 is. And so therefore, it is answer choice F. Now, let me try to hit off a few things here for your future use. A lot of people will look at the binomial and they'll see the 2 for the power, and they'll just distribute it to the x and the 1. Don't do that. That's not right. What we have here is a binomial squared. So you have to multiply the binomials together by FOIL. Please don't make that mistake, okay? By distributing your 2 to the x or your 2 to the 1. A lot of people believe that's a shortcut. That won't work. So I'm trying to eliminate future problems for you as we move forward too. What's our next question? Okay, we got a circle with a radius of 10 centimeters. Okay, so we have a circle. Let's draw a circle. And sometimes sketches are your best friends. Now, in the heat of the battle on the test, you don't have to make perfect drawings. Just draw them quick if you have to. And if you practice enough, you may not even need a sketch, because if you practice enough, you may do it so many times that you can just see it mentally. Okay, so a circle with a radius of 10 centimeters is divided into 3 congruent arcs. So we're going to have 3 arcs. So here's the center. I want to divide my circle into 3 pieces to try to make them about all the same. So I'm just going to start right here. And then I'm going to do this. Let me just draw it kind of like this. So I need about this distance around here. So maybe something about like that. That and that and that, they're roughly the same. And we know the radius is 10 centimeters. What is the length of each of the 3 arcs? So we want to know the length of the arcs here, from here to here, from here to here, from here to here. We want to know those arc lengths. Well, those arc lengths, what are they related to on the circle, the circumference? So circumference is equal to 2 pi r. We know that the radius is 10. So we know the circumference of the circle is 10 times 2, 20 pi. So we know the entire circumference of the circle is 20 pi. We want to know what is the length of each of the arcs. Well, if you take the 20 pi and you divide it by the 3 arcs, that gives us the length of each one of them. And in this case, they don't even want us to calculate it. They just wanted us to write it. So answer choice B. There you go. Next question. Now this problem, there's maybe out of, ever since 2016, there's only been a few students who could really get this correct. When you first read it, it's kind of irritating. And sometimes I think, why would they do this to you guys? This really reverts back to doing elementary math, fundamental things like simple division. So let's figure this out. So they have told us the fraction 2/7 is equal to, so they tell us 2/7 is equal to 0.285714. Notice there's 1, 2, 3, 4, 5, 6 numbers, and they put the repeating bar on it. So they're telling us these 6 numbers repeat. Okay, well, how far or how many times are they repeating? They're telling us they're repeating 1,001 times. So 1,001 times. Well, how many units of 6 are there in 1,001? So if you take 1,001 and you divide it by 6, What we find out is 6 goes into 10 one time. That leaves 10 minus 6 for 40. The closest we can get to 40 is 6, so 36. So 10 minus 6 is 4. That's going to give us a 41. The closest we can get again is 6. So that's 36. Well, 41 minus 36 is 5. So we get a remainder of 5. So 166 with a remainder of 5 over 6. This remainder is very important. We're talking about numbers, right? So it's telling us the 166th group of 6th with the 5th number of the 6 is our remainder. So if we take our number 0.285,714 and we count over 5. 1, so we start with 2. 1, 2, 3, 4, 5. We end up at 1. Therefore, the digit in the 1001st decimal place is number 1. Answer choice F. That problem is just a little aggravating because, unfortunately, you're doing so much algebra at this point in your life, or most of you are anyway. Some of you have been through Algebra 1, Geometry, Algebra 2, and perhaps you're in pre-cal, or perhaps some of you are taking calculus by now. You just don't think from this perspective anymore. It's just an aggravating problem. Believe me, I feel your pain. Let's go on to the next one. Okay. At what point in the standard coordinate plane do the asymptotes of the function graph below intersect? This is another problem that kind of irritates me. I'm going to draw on top of the picture. So let me change colors so the color will be apparent. All right, so we're good there. Some of you are in Algebra 2 right now. I don't know where you're at in your course curriculum. I don't know if you've been taught about vertical asymptotes, horizontal asymptotes, or slant asymptotes. But as you move forward in the courses, your teachers are going to talk about those asymptotes. In this case, we can visually draw in our asymptotes to quickly predict what this answer is going to be. Because of the format of this graph, we know that these lines, let me make sure this is still red, yeah. We know that this line's going to go like this and continue. And this line's going to go just the same slope and continue. And this one's going to do the same thing down here. Got it? Now, this line here continues, and this one continues to follow the same thing. Now, what we want to do, we're we're going to draw a line that these two graphs are approaching. I'm going to draw a dotted line going straight up the best that I can. And then draw it coming straight down. Now my line here, let me correct it. Let me correct this line right here. Let me get a little bit better. So it's going to come back down like this, and it's going to approach 3, but it's never going to cross it. Now we got a vertical asymptote between this graph, but notice this line flattens out, and then this line flattens out too, like so. So there's a relationship between this portion and this portion, and this portion goes somewhere. I want to just try to sketch it in the best that I can without touching it. Now they cross somewhere in here. Okay. They cross somewhere. Well, maybe I could have sketched it a little bit better. I started too high. I started too high down here. So let me go back here and get rid of this line for a second. Just bear with me. I needed to start closer. Let me get rid of that dot. Draw. Red. Okay, so I'm right here, and I'm going to go the best that I can. Somewhere around that. Now, they're crossing like right about here. All right. It says at which point on the standard coordinate plane do the asymptotes graph below intersect? So we're looking at something about 3, and we got about 15-ish, right? Now, we're sketching this in to do this question quickly. With that being said, we know it can't be F. You know it can't be G, because that says -7/3, and then 10. So those are gone. But 3s all work in H, J, and K. H has 10. 10's not close to our point, so H is gone. J has 3 and then 16. 16 is very close to where our dot is at. K has a 31 for the Y value, so it would be way up here. So it can't be K, so it has to be J. Now, with this being said, I don't know where you guys are with your math curriculum. And some of you that are just in Algebra 2 at this point, and you're having to take the ACT in your junior year, you're behind in your math. That's okay. You're just going to have to take the ACT during the summer of your senior year, or before your senior year starts. So that's going to put more pressure on you. I'm not going to go into the math course timeline because that's not what this is about. But in this case, I didn't use any mathematics to determine the intersection. I just used a vertical asymptote and a slant asymptote based off the knowledge I have from recognizing portions of the given graph. You'll get there. You'll get there as your teachers lead you through this more. I'm not going to carry you through the long, arduous math. It's not worth it. Let's go to the next question. Alrighty. So this question, there's no figure or anything, so we gotta read it. The employees at a hotel reservation center assign an 8-digit confirmation number to each customer making a reservation. The first digit in each confirmation number is 8. All right, so let me change my color of my pen back to white. So we know it's an 8-digit number. So 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers. The first digit in each confirmation number is 8. The other 7 digits can be any digit 0 through 9. So 0 to 9, 0 to 9, 0 to 9, 0 to 9. I think you get what I'm doing. So 0 to 9 is actually 10 numbers, right? And it says these other 7 digits can be any digit 0 through 9, and the digits may repeat. How many possible 8-digit CNs are there? Well, each one of these are 10. 10 total numbers, 0 to 9, right? And no matter what, this first number never changes. It's always the same. So the only variation that you get with this number is with 1, 2, 3, 4, 5, 6, 7. These 7 sets of numbers. So that is 10 to the 7th. So how many possible 8-digit CN numbers are there? 10 to the 7th numbers. Answer choice C. Let's move on to the next one. Okay. Not too many people talk about the determinant. I'm just going to have to give you the information, the formula for determining the determinant of a matrix. So the symbol for that, the mathematical symbol, if they ever give it to you, is it looks like the absolute value of A. Here's how we determine the determinant. So A, B, C, and D. So here's our matrix. This is our formula. To determine the determinant, we're going to say A times D minus B times C. Let's replace our numbers in this fashion now. 8, 3, -5, -2. Use the formula, A and D. So 8 times -2 minus B, 3 times -5. Eight times -2 is -16. Okay, now this is a -3 times a -5, so that's going to make that a positive 15. Be very careful with your signs. So -16 plus 15 is going to be -1. So the determinant is -1, or answer choice C. This is the formula, AD minus BC. be careful with your signs here, because this -3, this negative sign is associated with the 3. A lot of people make a mistake by not using the signs properly. All right, only a few more questions and we're done. So this is a good one. What is the distance in coordinate units between 2 plus 6i and -4 plus 3i? Imaginary numbers, coordinate plane. How do we use the coordinate plane here? So I'm going to show you. Normally, this is our y-axis. And this is our x-axis, normally. But now we're putting imaginary or complex numbers on our graph. So our complex numbers are going to be graphed on the y-axis. We're going to change y to I. And we're going to leave x as normal. So the complex portion of our number will be graphed on the I-axis. So we got 2 and -4. So let me just make some tick marks here. 1, 2, 3, 4, 5, 6. It doesn't have to be perfect, but keep them spaced as equal as you can. So let's go to the first one, -4, 1, 2, 3, 4, and 3i, go up 3, right about there. And then 2 and 6i, so 1, 2, and go up 6. So 6 would be right here. What is the distance between the 2 points? We want the distance between these 2 points. Well, check it out. Here's what we can do. Always leverage what you know about graphs. So in this case, I'm going to draw a line straight across the best that I can. And then I'm going to draw a line straight down the best that I can. Okay, forms a right triangle, right? Now we know this value here is 2 and 6i. So we know this is 2, 6i, which is 6. And then we come across here, and this becomes 3. So this point right here would be 2, 3, right? So the distance from here to here is 6 minus 3, 3. The distance from here to here is 2 over and 4, so a total of 6. Now we need this distance. Well, I just set this up. As a right triangle. So now we can use Pythagorean's theorem. A squared plus b squared is equal to c squared. 6 squared plus 3 squared is equal to c squared. 36 plus 9 is equal to c squared. 45. 36 and 9 is 45. It's equal to c squared. So the square root of 45 is going to be equal to c. Hence, answer choice D. Okay. Look what I used to get us to the answer. I used a graph. I graphed the points on my sketched graph. And then I recognized I could make a right triangle, and I used Pythagorean's theorem to help us find the distance between the 2 points. Now, this is right at about an hour. That's a little longer than what I wanted to make this. So I'm going to end it right here. With that in mind, I hope this helps you guys. And I hope you pay attention to the logical ways that I went about solving this. Are there other logical approaches to these questions? Yes, but I'm not going to work them all out many different ways. My purpose is to get you to thinking from an application conceptual basis to solve these problems. And if you begin to switch your mindset to using mathematical concepts to solve problems, you're on your way to making a really good score on either the ACT math or the SAT math section. Okay. With that in mind, I wish you all the luck on your studies for your test preparation. And if I can ever be a help to you, reach out to us. You guys have a great day.